Okay, we're starting with 17.1, understanding polynomial expressions. And this lesson starts with a ton of vocabulary. Make sure you're taking good notes. Okay, the first vocabulary word is monomial. A monomial is a number, a variable, or the product. Remember, product means the answer to a multiplication problem, or it's the product of numbers and variables. And they will have whole number exponents, with whole number exponents. So you won't have any negative exponents, you won't have fractions or decimals as your exponents. So to be a monomial, it can be a number, a variable, or a product of those. And it can only have whole number exponents. And I'm going to give you some examples of monomials. And then I'll give you examples that are not monomials. So a monomial can be a number. So like 4. 4 is a monomial. It could be a variable. So the letter x, that's a monomial. Or it can be the product. Product is multiplying. So something like 0.25 x cubed. Because we're multiplying 0.25 times the x cubed. The cubed is a whole number exponent as well. We could have negative 5xy, because those are products. We can have a fraction as long as your variables are on the top as the numerator. So xy divided by 4. As long as the letters are on top. If they're the numerator, that's fine. It's a monomial. Okay, examples that are not monomials would be something like 4 plus x. I can't have a plus sign. 4 by itself is a monomial. X by itself is a monomial. Together, they're not a monomial anymore. Or subtraction, x minus 1. That's not a monomial. Having a negative on the exponent, so something like 0.7 x to the negative second power. I can't have a negative exponent. 0.25 x to the negative first power. That's not a monomial. I also cannot have fractions where the variables are as the denominator. They can't be on the bottom. So y over x cubed. That's not a monomial. Okay, so there's examples of monomials, and then these are we're just going to call them not monomials for right now. Okay, the next vocabulary word is term. And we've done terms before, so this should just kind of be a review like, oh yeah. Terms are your parts that are separated. Parts that are separated by a plus or minus sign. Parts that are separated by a plus or minus sign. So for example, 15 plus 9x minus 6y minus 5xy. Each term is separated by the plus or the minus sign. So 15 is a term, plus 9x is a term, minus 6y is a term, minus 5xy is a term. So there's 4 terms. Every time you get to a plus or a minus sign, it goes to the next term. That symbol, the plus or minus sign, remember, it goes with the number that's right behind it. So that's 6, it's really a negative 6y. Okay, next one, polynomial. Polynomial. That can be a monomial. A monomial, or the sum means adding up, or the sum of monomials. Then we have a binomial. A binomial has 2 terms. So for example, something like 5x plus 7. Because every time you have a plus or a minus sign, it splits up to a new term. 5x is a term, plus 7 is a term. So that has 2 terms, so it's called a binomial. Or something like 4a squared b minus 6a. It has 2 terms, so it's called a binomial. Next one is trinomial. A trinomial has 3 terms. I know it's a lot of writing today. This is the only lesson that's like this. It has so many vocabulary words. Trinomial might be something like 8xy squared minus 5x cubed y cubed z plus 2xy. This is a trinomial because it has 3 terms. Okay, next one is degree of a polynomial. Degree of a polynomial. This is the greatest value among the sums. Remember, sum means add. Among the sums of the exponents on the variables in each term. It's the greatest value among the sums of the exponents on the variables in each term. What that means. And we'll do practice on this also during the lesson. It's a little confusing at first. So if I take 8xy squared minus 5x cubed y cubed z. I'm going to look at their exponents and I'm going to find the sum. I'm going to add up the exponents. So if I look at each term, if it helps, box them. So there's two terms. Two terms means this is a binomial. Okay, we're only looking at the variables because the number in front, the coefficient, it really has a 0 exponent on it, so don't worry about the exponent that's on the whole number, or not even the whole number, but whatever the coefficient is. The tricky part comes from the variables that have no exponent on it. You have to remember that when there's no exponent, there's really a 1 up there. So what you're doing is you're adding up the exponents. 0 plus 1 plus 2. This one has a degree of 3. This term has a degree of 3 because I added 0 plus 1 plus 2. Here, negative 5 has a degree of 0, not a degree, an exponent of 0. X has a 3, y has a 3. Z has no exponent showing, so there really is a 1. And now I'm just adding up those exponents. Oops. 0 plus 3 plus 3 plus 1, 6, 7. That has a degree of 7. So then you take the biggest degree. 7 is the bigger one, so this is called a 7th degree binomial. Because 7 is the bigger of the two sums. And we'll do practice on that today. We have 2 more vocabulary words. Next one is standard form. Standard form. When we write a polynomial in standard form, it is written in terms in order of decreasing degrees. It's written in terms in order of decreasing degrees. And I'll go over what that means when we get to that problem because it's a little confusing to explain it right now. The last vocabulary word is leading coefficient. A leading coefficient. It is after you write standard form, after being written in standard form, it's going to be the coefficient. Coefficient, remember, is the number that's touching the letter. We did this a ton in August. The coefficient on the first term. Okay, now we're going to start the examples. Give your poor little hand a massage. I know that was a lot of vocabulary. Make sure your notes are nice and neat. If you missed anything, get it from a neighbor. This lesson is going to take us 2 days. We'll get through, I think, 2 of the examples today, and then we'll do the last 2 tomorrow. Does anyone still need this up? I'm going to go to a new page then. Okay, example 1 is going to ask us to classify the polynomial so tell me what it's called and the number of terms. So you have to give me two answers for these. You'll have to tell me what the polynomial is called and how many terms it has, excuse me. Okay, 1A. Just so you know, there's a ton of letters in this lesson. 7x squared minus 5x cubed y cubed. Okay, the first thing I'm going to do is figure out how many terms there are. So every time you get to a plus or minus sign, you stop. And that plus or minus sign goes with the next number. So that minus sign is attached to the 5. Make sure you understand that. So there's 2 terms. When I have 2 terms, that's called a binomial. Bi means 2. So binomial has 2 terms. Now I have to discuss the, oh, is that all it's asking me? Oh, it's asking for the degree too. Sorry, I didn't put that in my directions. And the degree. I knew I was missing something. And then I gotta tell what the degree is. So to find the degree, I'm adding up the exponents. So 7 has an exponent of a 0. X has an exponent of a 2. So the degree on that first term, 0 plus 2 is 2. Okay, negative 5 has a 0 exponent. X has a 3, y has a 3. So you add up 3 plus 3 is 6. So you take the bigger of the 2 degrees. So it's a 6th degree. Or we call it a 6th degree binomial. Okay, let's try another one like that. 3 squared plus 2n cubed plus 8n. Now this one, they're trying to trick you at the beginning. 3 squared, I need to finish that. That's not actually finished. 3 squared, 3 times 3 is really 9. So go ahead and actually fix that to say 9. 3 squared is 3 times 3. Okay, now I can figure out how many terms, what's it called, and what's the degree. So 9 is a term, 2n cubed is a term, and 8n. So every time you get a plus or a minus sign, it's a new term. So there's 3 terms. That's called a trinomial. Tri means 3. Okay, then I have to discuss or figure out the degrees. 9 has a degree of 0. 2 has a 0 on it, n has a 3 on it, 0 plus 3, this has a degree of 3. 8 has a 0 on it, n has a 1 on it. Remember the variable has a 1 on it. So that has a degree of 1. Because your letter n really has a 1 in the R. Okay, you take the biggest one, it's 3, so this is a 3rd degree trinomial. Okay, now you're going to do some on your own. You can work on these with the people around you. Number 1, 3x squared y squared plus 3x y squared plus 5xy. Okay, go ahead and classify what's that called and tell me the degree. There's 3 terms. 3 terms is a trinomial. 3 has a 0 on it, 2 and 2, so this has a degree of 4. If I add up 0 plus 2 plus 2, I get 4. That has a 0. The x has a 1 on it, so the degree here is 3. This has a 0, this has a 1, this has a 1. I add up the exponents. 0 plus 1 is 2. So the biggest degree is 4. So this is a 4th degree trinomial. How many people did get that one right? Okay. Either this is like a super easy lesson or people get completely confused. Okay, let's try another one. Number 2, 8ab squared minus 3a squared b. Okay, so the biggest degree is 3, so it's a 3rd degree. And there's 2 terms, so it's a binomial. 3rd degree binomial. How many people did get that one? Okay, fairly easy. Okay, now we're going to move on to example 2 then. Make sure it's nice and neat, because you know you're going to walk out of here and you forget everything you learned. So right now you're thinking this is so easy, and then you're going to come tomorrow and have to work on the exit ticket and be lost. So check your notes. Are you writing everything down so you can go back and read your own notes? For example 2, it's going to say to write it in standard form. And I want the leading coefficient. So to get the leading coefficient, you have to put it in standard form first. Okay, 2a. 20x minus 4x cubed plus 1 minus 2x squared. Okay, so this is what I'm talking about, that it gets a little confusing at first. So standard form, we have to put it in order of degree. So we have to figure out how many terms there are and what the degree is of each term. So what I usually do is just kind of make markings for each degree, if that helps you. So every time there's a plus or minus sign, that's a new degree. So just so you know, there's 4 terms. Did I say degree? There's 4 terms. Each one's a new term. 4 terms, that makes that a polynomial. Okay, the degrees then. I'm going to go ahead and figure out what the degree is of each term. 20 has a 0 on it. X has a 1 on it. So this degree is 1. Negative 4 has a 0 on it. X has a 3 on it. 0 plus 3 is 3. This 1 has a 0 on the exponent, so it has a degree of 0. Negative 2 has a 0. X has a 2. 0 plus 2. So you're just adding up the exponents. Okay, to write this into standard form, we write it in order of descending degrees. So the highest degree always goes first. You have to be careful though, if it has a minus sign in front of it, keep that minus sign. So we're starting with the biggest degree of 3. So this is the term that's going to go first. Keep in mind you have to keep the symbol in front. So in standard form is how you're always going to write your answers. You're going to use standard form for the next 3 years of your math career. Okay, so that term is negative 4x cubed. That goes first. So I used that. My next highest degree is the 2. So this term, minus 2x squared. Then the next one is the degree of 1. Since there's no symbol in front, there's really a plus sign, right? So put a plus, 20x, and then the last degree is the 0, that's the plus 1. So here's our standard form. Negative 4x cubed minus 2x squared plus 20x plus 1. And then leading coefficient. So coefficients are the numbers that are touching the letters, right? They're at the very front of the letters. So the leading coefficient means just what's in front. So it has to be written in standard form first, and then the leading coefficient is a minus 4. If it is a negative, you have to put a negative. If not, if you put positive 4 as your answer, you're going to get that marked wrong. Okay, let's try another one. Z cubed, and you'll notice when I write z's, I put a little line through them because too often when you write a z, it ends up looking like the number 2. So if you look at your z right now, does it look like a 2? Because on a test, if I can't tell, I'm going to mark it wrong. Make sure it looks like the letter z and not like the number 2. Okay, z cubed, where am I? There. Minus z to the 6th power plus 4z. Z cubed minus z to the 6th plus 4z. Make sure your z's don't look like the number 2. Okay, first we're going to figure out how many terms there are. So every time you get a plus or minus sign, that's a new term. So there's 3 terms here. Figure out what's the degree of each term. So add up the exponents on every variable. So for this term, there's just a 3. On this term, there's a 6. The 4 has a 0. The z has a 1 on it. Any variable always has a 1 as the exponent. So this one has a degree of 1. Now to write it in standard form, we put it in order from the biggest degree to the smallest degree. So the biggest degree is the 6. So we're going to put that term first. Minus z to the 6th power. So I'm done with that guy. The next biggest is the degree of 3. Since there's no symbol in front, it's a positive. So put plus z cubed. Okay, we're done with that one. And then we finish with plus 4z. There's standard form. And then I need the leading coefficient. So the number that's in front. By now, you guys understand when I have a letter, there's always a 1 in front of it. So there's a negative in front. We know there's really a 1 right here. So the leading coefficient is really a negative 1. When you don't see a number in front of the letter, there's really just one of that letter, so there's a minus sign, so it's really a minus 1. Okay, the rest of these that we're doing, you can work on them with friends. So go ahead first, write this down, and then if you want to move around and work with a friend, you can. We're going to do 4 of them. Okay, first write this one down, number 3. 10 minus 3x squared plus x to the 5th plus 4x cubed. 10 minus 3x squared plus x to the 5th plus 4x cubed. Okay, you can move around. You can go work with another friend. Write it in standard form and then tell me the leading coefficient. Okay, in standard form, x to the 5th power plus 4x cubed minus 3x squared plus 10. And then the leading coefficient, the number in front, there's really a 1 there. Leading coefficient is 1. Questions on that one? Yay? Okay, here's the next one. You can do it with your friends. Um, 10x plus 13 minus 15x squared. Write that in standard form and tell me what's the leading coefficient. Okay, standard form is negative 15x squared plus 10x plus 13. And the leading coefficient is negative 15. How many people are getting this so far? So good. Okay. Then I'm going to put the next two up for you. Number 5 is 18y to the 5th minus 3y to the 8th plus 10y. Come up with standard form and leading coefficient. And then when you're done with that, I'll have number 6 up here for you. So for number 5, check your answer. Negative 3y to the 8th power plus 18y to the 5th power plus 10y. Leading coefficient is a negative 3. Okay, if you haven't done number 6, go ahead and do number 6. It's kind of long. This one well, we're actually going to end up a negative 7 and a plus 7 are just going to be 0, so I wouldn't even write them. I'd just take them off. Yeah, I mean, you could put them, and then it doesn't matter which one you put first. You could put the minus 7 or the plus 7. I wouldn't, like if it's a paper test, I wouldn't mark it wrong. If you're doing HMH, I'm not sure if they're going to make you just drop it completely. My guess is they probably want it dropped completely. But if it's a test for me, I'm okay if you put it. And yeah, it just hasn't been simplified. Yeah, and then if they have the same degree, it doesn't matter which one you put first. This is a 2, 1, a 3, and a 4. Okay, standard form here is 12b to the 4th power plus 6b cubed minus 3b squared plus 2b. And then if you wanted to have the plus 7 minus 7 at the end, I'm okay if it's there. I would just simplify it. Minus 7 and plus 7 makes 0, so I'd just take it off. HMH, I don't know how they're going to grade that. I would assume they probably want it completely off, though, for HMH. The leading coefficient is 12. Okay, so far, how are we doing? Not too crazy? Okay. Okay, we're going to start the next example, and then we'll stop. And then I have a few people that still need to work on their tests. Does anyone still need this up? Good here? Okay. Example 3 is combining like terms, which you guys have done before. So when you have something like r squared plus 5r cubed plus 2r squareds. So the thing that's new for you guys, so you're used to combining like terms because we did this in the first chapter way back in August. But now we're going to have variables that look like they're the same, but they're not the same. So you guys are used to like there might be an r. but we have an r squared, we have an r cubed, we have an r squared. R squareds and r cubes are not the same terms, so the exponent does matter. So here I have 1 r squared, I have 5 r cubes, and I have 2 r squareds. The only two that go together are these two, the first and the last one. These are like terms because they both have the same exponent. They have to have the same exponent or you can't put them together. Just because they have an r, that doesn't make it the same because this is r cubed. The exponent does matter when it's on these letters, on the variables. Correct. Yeah, the coefficient is not, we're about to combine them and just add those together. We're going to put this in order. So there's 1 5r cubed, right? There's just one of those terms. So there's 5r cubes. But there's an r squared, and then there's 2 r squareds. So if I already have 1 r squared, and then I add on another 2 r squareds, I now have 3 r squared. So you're just adding up the coefficients, the letter, the variable, and the exponent that's on the variable stay there. So we're going to practice that. We're only going to do 1 today, and then we'll finish this tomorrow. Okay, so for 3a, negative 2y cubed minus 8y squareds plus y squared plus 2y cubed. Okay, if it helps you to block and see each term, this is what I usually just do so my brain can see it. So I see there's 4 terms. I'm looking for like terms, which ones have the same letter raised to the same power. So this has a y to the 3rd power. This is a y to the 2nd power, so that's not matching. That's y to the 2nd power. So that means these two are like terms because they both have y squareds. And then we have a y to the cubed over here. So this y cubed, the first y cubed, and the back end y cubed. Those ones are like terms because they have y cubes. It has to have the same letter raised to the same power. So the exponent has to be the same to put them together. You should get in the habit of always writing stuff in standard form. So something that has the bigger degree. So the degree here is 3 versus the degree on these guys are 2's. So let's put the 3 first. If I have negative 2y cubed, and then I add 2y cubes. So I have y cubes, I have negative 2 of them, and then I have positive 2 of them. So they've canceled each other out. I now have I have 0 y cubes. Some of you still write that. I would get out of that habit. If you have 0 y cubes, 0 times that is just 0. So you don't have to write down 0. But just know there's 0 of them. So I used those. Then for the y squareds, I had negative 8y squareds, and then I added a y squared. Negative 8 plus 1 is negative 7y squareds. And again, I don't want to put this 0. You don't need to write it. It's basically redundant. So your final answer would be negative 7y squareds. And I think that's all we had to do for that one. Yeah. Okay, we will continue on with this tomorrow. Check your notes. Make sure they're nice and easy for you to follow for tomorrow.